All right, welcome back. And today we are talking about section 5.4, which is on working with integrals and some of the kind of cool properties of integration. And then next time on Friday, we'll talk about our last section, which is integration by substitution. For everybody who is going on to Calculus 2, is that most of you? I would assume most of you are probably taking Cal 2. I would say that the next section is one of the most important sections for Cal 2. So I know it's the end of the semester and it's kind of like me in some ways at the end of the semester, but what I would really encourage you is to take your time with the next section because you'll use it almost every day in Calculus 2. So it's worth getting, okay? It's not one that you want to get to Calculus 2 and be like, yeah, I don't really remember this. I'm not very strong with this. You want to be strong with this next section. So when you're going through integration by substitution, you really need to get it pretty well. Okay, so just keep that in mind. You will thank yourself later in Cal 2 if you really get section 5.5 well. Okay, so, and of course, we have a final coming up, correct? Does anybody off the top of their head remember what day it is? It's Friday, okay. Friday at 8 in the morning. Yeah, all of my finals this semester were scheduled for 8 in the morning. I guess I'm just lucky that way, but yeah, Friday at 8 to 10. And one thing that's kind of interesting is like the whole idea of like we don't actually have space in the classroom theoretically with COVID to have everybody in the classroom at that time. So I need to think about that a little bit. I'll talk about that on Friday, how we're going to figure that out. I don't know if anybody's really thought about that very much, but it's something I've thought about is if usually we have 2 different test times and they didn't schedule us 2 different test times. So what will we do? I'll figure it out and I will tell you on Friday. Okay, any homework questions that you'd like to talk about? Yes, sir. Sorry?
37.
37? Okay. So 37 is on average height of an arch. So you have an arch above the ground given by y equals 10 sine x. Okay. So this is 37. And you have y equals 10 sine of x. For 0 less than or equal to x less than or equal to pi. So what's the average height of the arch above the ground? So we've got that 0 is less than or equal to x is less than or equal to pi, and they want the average height of the arch. Okay, so first of all, from 0 to pi, sine kind of does this sort of thing, right? So here's kind of our arch, except usually it goes up to 1, but this 10 will make it go up to 10. All right, and they're saying, well, what's the average height? So if you took the average over all of these things, what would it be? And the way that we find average over an integral is we typically integrate the function and basically find all the area under the function. And then we divide it by, well, how much distance did we cover? And it's actually very similar to when we average like exam scores or something, is if we have 3 exams, we go 1, 2, 3, and we say, okay, how much do we score on each exam? And we add up the area, so to speak, and then we divide by 3. So this is very similar. So what I want to do is I want to say, okay, so what's the integral from 0 to pi of 10 sine x dx? But then I want to, if I'm trying to find the average, then I want to divide that by the length of the interval. And this is from 0 to pi. So the length of that interval is pi minus 0, or just pi. So that will give it to us. We could bring the 10 out if we wanted to. So if we do, we get 10 over pi times the integral from 0 to pi of sine x dx. So we need to take the antiderivative of sine of x. We still have this 10 over pi hanging out. What's the antiderivative of sine of x? So cosine's derivative is what? Negative sine. So whose derivative is sine? Negative cosine. That's right. So we're going to write this as negative cosine of x evaluated from 0 to pi. Okay. So we've still got this 10 over pi sitting here. 10 over pi. And then we plug in our pi and we get cosine of pi. What is cosine of pi? Negative 1. So we've got minus 1. So we've got minus 1. And then we subtract, plugging in 0. If I plug in 0, I get cosine of 0 is 1, correct? And so I get minus 1. So I subtract minus 1. Okay, which gives me 10 over pi times, this is 1 plus 1, that's 2. So I suppose it's 20 over pi. Now, if in doubt, it never hurts to think for a little while and think, does this make any sense at all? So this arch has height 10. It has width pi. So I suppose that this thing, if I were looking at this big rectangle's area, then what would I get? I guess 10 pi, right? 10 times pi. And 10 times pi is like 34, right? So, and so what would I expect, and also what would I expect the average height to be? So I would say it's kind of like in here somewhere, right? Is the average height of that arch. And so what would we expect it to be? Well, I mean, maybe a little lower than 5, maybe a little bigger than 5. It's hard to say, but somewhere in that range. And so what's 20 divided by like 3.14? It's a little bigger than 6. Is that right? And so this is saying that the average height is a little bigger than 6, but is it at least plausible that it's a little bit bigger than 6? Yeah, I think so. It's somewhere between 0 and 10, and it should be kind of towards the middle. Maybe I would have guessed around 5, but 6 seems plausible. So that's good. Other questions? Yes, sir.
So in the ones where we use symmetry to evaluate the integral,
yes.
How again do we get the 2 integral then 0 to 2 going from, or like for example, like number 13.
13.
13
Yeah.
or 11. How do you get that like 2 on the 2 on the outside? Is that something just for that specific integral from -2 to 2, or would it change if you went from -4 to 4?
Yeah. So what's happening here? So you've got -2 to 2. And what's inside? Is it 3x to the 8th or something?
Yeah.
-2. Is that right?
Yes.
Dx. And they're saying, okay, so what's this integral? And they're saying use symmetry, right? Okay, so we can talk about what an even function or an odd function, right? And even functions have this nice property that they're symmetric across the y-axis. So they're a mirror reflection of themselves. So let's say we don't even care what the function is. I don't care. It's just some function. I'm not drawing this function, by the way. So I just know that whatever it is over here, it's the same over here, right? It's a mirror image on that side. And so if I know that my function is an even function and it does something like, I don't know, maybe it does something like this on this side, then it does something like this on this side. It's just a mirror image. So if I'm trying to find the area under a mirror image, it's gonna be the same, right? So yes. So the answer to your question is, if it's -4 to 4, then yes, you can still just go from 0 to 4 and double it.
Oh, okay.
Does that make sense? So it's kind of like what you're saying is that if this is a mirror image, then I could just take half the mirror and double it. And that's something that we'll do all the time in calculus too, is we'll use symmetry to make it easier. And one thing that's always nice to have in an integral is 0. Because plugging in 0 to things is typically kind of wonderful, right? And plugging in -2, it's not horrible, but it's not as good. So the way that we would typically do this is we would just say, oh, this is an even function because the powers of x are all even. So instead of integrating from -2 to 2, we could just go from 0 to 2 and double it. Because it's just a mirror, right? And so we can just double 1/2 of the mirror, so to speak. And so then this is of 3x to the 8th minus 2 dx. And now this is fairly easy to compute. We can take 2. The antiderivative of 3x to the 8th is 9 divided by 9. So this is 1/3 x to the 9th. And then this one would be -2x, evaluated from 0 to 2. And already, like, us using symmetry is kind of bearing fruit because we're going to get to plug in a 0, which is very nice. So we just get 2 times. If I plug in 2 here, that's a little bit annoying, 2 to the 9th. What would that be? 2, 4, 8, 16, 32, 64, 128, 256. What? 256, that would be 512.
Yeah.
Yeah, 512 divided by 3. -4. And then that's plugging in the 2, but plugging in the 0 is very easy. It's just 0 minus 0, which is 0. And so what do we get? So 4 is how many thirds? 12 thirds, correct? So we've got 512 thirds minus 12 thirds is 500 thirds times 2 is 1,000 thirds.
Yeah.
Yeah. So that's it. Make sense? So really these symmetry things are pretty easy. And symmetry definitely makes integration easier if you can use it. Now, something you have to be a little bit careful of, this isn't in this section, but later you'll come across something like this. And if you were going to like 3, then it's just all gone. You can't do it anymore because it has to be symmetric, a symmetric interval across 0. So since it's from -2 to 3, you can't use symmetry. If it were from -3 to 3, you could use symmetry. So this only works because of the nice symmetry of the interval across 0. Oh, Somebody's saying something on here. Let's see. Oh, yeah. Are you? Oh, okay. That's good. Somebody said 18. So let's do number 18. So we've got negative pi over 2 to pi over 2 of 5 sine theta. Okay, we've got integral of negative pi over 2 pi over 2 of 5 sine theta d theta. All right, so the question is, what kind of symmetry does the sine function have? Does it have odd symmetry? And when I say odd symmetry, oftentimes I'm talking about there's symmetry across the origin. And what I mean by that is an odd symmetry, like sine is a good example of an odd symmetry actually, because the first kind of like hill of the sine function goes like this, and then it goes back like this. And so what I mean by symmetry across the origin is if I draw a line through the origin, these points like correspond, but they're negatives of each other, right? And if I drew some other line through the origin, those points correspond, but they're negatives of each other, right? So if you take an x value over here, f of x here is negative f of x over here. So that's an odd function. And it just so happens that polynomials that have odd powers, all odd powers, like x cubed, x to the 5th, x to the 7th, those kinds of things, they're all odd functions, which is why we call them odd, is because polynomials that have all odd powers are odd functions. But sine is also an odd function because it has this property that if you take x and you take negative x, the functional values are negatives of each other. Okay, so now that we know that this is an odd function, I could always take the 5 out if I wanted to. So I have 5 integral negative pi over 2 to pi over 2 of sine theta d theta. This is an odd function, but what happens if you integrate an odd function over a symmetric interval? It's just 0. And why is that? Because like up here, the area, and down here, this area, those are this is positive area, that's negative area. When you add them together, it's symmetric, so they're exactly equal. And so you just get 0. So in this case, it's very easy. I don't have to even take an antiderivative. Since I know that this is an odd function, this is just 5 times 0, which is 0. Sound good? Yes, sir.
So I know you kind of covered this in the examples, but I don't understand really, like in question 23, when
Yes.
you have a function over a function, how you can decide if it's a resulting odd or even function.
Yeah. That's a good question. Okay. Let's look at 23. Would you read it to me? So it's integral of what?
Negative 2 to x cubed minus 4x over x squared plus 1 dx.
Thanks. Okay, so negative 2 to 2, so we've got a nice symmetric interval across the origin. But the question is this an even function or is it an odd function, right? Now, let me ask you a question first, and then you can help me with the other part. What if I just took the bottom out? Then it's obviously odd. Agreed? So that's an odd function. And the question is, what does the bottom do? Well, in this case, the bottom doesn't do that much. It just scales because the bottom is always positive. and the bottom is also symmetric across the origin. So in this case, this is an odd function. Because if you plug in, okay, here's another way of thinking about it. What's the true definition of an odd function? An odd function is one where if you take f of negative x, you get negative f of x. Does that make sense? And on a graph, what I'm saying by that is like, let's take our sine function again. If I take negative x and I take its functional value, that's the same as taking x, finding f of x, and taking that thing's negative. So f of minus x is negative f of x. That's one way of thinking about an odd function. So if you're ever in doubt if something's an odd or even function, first of all, if you're ever really in doubt, you could just kind of like can it and integrate it, right? But in this case, that's not so easy to integrate. So it would be very nice if it were odd. One way you could always tell is you could say, well, just plug in negative x to it. Now I can see just from experience, this is an odd function. And the reason is because this thing doesn't affect it because it's the same on both sides of the origin. So it's, in some sense, you could almost say that an odd function divided by an even function is an odd function, which kind of makes sense almost, right? That it's like, well, maybe it doesn't, I don't know. But let's plug in negative x and see what happens. So if I plug in negative x cubed minus 4 times negative x divided by negative x squared plus 1. The question is, would I get the negative of this thing? And let's see. So what I'd end up with is I could, negative x cubed is the same as negative x cubed. This is plus 4x divided by, if I square negative x, I just get x squared plus 1. And on top, I could factor out a negative. If I did, I'd get negative, and on top, I'd have x cubed minus 4x divided by x squared plus 1, which is the negative of what I started with. In other words, f of negative x, which is this, was equal to negative f of x. And that's actually the definition of what it means to be an odd function. So yes, this is an odd function, but how would I see it without having to compute anything? I would just say, well, this thing is certainly symmetric across the origin. This guy is symmetric across the y-axis. So negative x's do the same thing as positive x's for the bottom. For the top, there's this like negative symmetry. So what's going to end up happening is, well, negative symmetry. Does that kind of make sense? And if in doubt, you could always like do it the old-fashioned way and plug in a negative x and see if you get negative f of x. Yeah. Other questions? Yeah.
Can you do 25?
Sure. 25. So we want to find the average value of that function over the given interval. Okay. Okay. So we've got f of x equals x cubed on negative 1 to 1. So we've got f of x equals x cubed on the interval from negative 1 to 1. So what we're really asking for is if we want the average value of that function, is we want the integral from minus 1 to 1 of x cubed dx, but then I'm going to multiply by something to get the average value, 1 over the length of this interval, which is b minus a, or 1 minus 1. In other words, 1 over 2, which is the length of that interval. Okay, so we get 1/2 times the antiderivative. Now, there's two ways that I could do this integral. I could just do the antiderivative, but we just were talking about even and odd functions, and this is an odd function over a symmetric interval across 0, right? So what is the value of that integral? Yeah, it's just 0. Now I could actually take the integral and I'd also find 0, but this is just times 0. So the answer is 0. So the average value of this is 0. And that kind of makes sense because if I were to graph this thing, right, this is from, here's 1, here's negative 1. So this is my graph, right? And I'm saying, what's the average value along this whole interval? Well, it's symmetric up here to what's down here. So we would think that the average would be right in the middle. And it is 0. Other questions? Okay, very good. So today we have this homework is due tonight. We have one more assignment due Friday night. So Friday we'll go over substitution, which, just another reminder, very important section in Calculus 1. It's kind of sad that it's the last day, but it is what it is. And then we'll also talk about what to expect on the final. Okay, so we'll talk about that on Friday as well. All right, have a good day, and I will see everybody Friday.
Excuse me, I was
Yeah.
wondering if I took this correctly, because you said you could do it with the antiderivative.
Oh, yeah.
If I keep getting 1 over 4.
You did do it correctly, but then you should get, you plug in the 1 and you get a 4th, minus, plug in the negative 1 and you get a 4th. So it's minus 1/4.
That is nice. Thank you.
Yes, sir.
Am I able to get in touch with
Yeah, what's your last name?
Price?
Price?
Yeah. This one I had a question on.
Yes.
I was kind of confused.
Yeah, so that one was, I hate to say it was a trick question, but
Yeah.
it was at least tricky. Let me say, okay, so this is the limit as x goes to 0 of 1 over, what's the x squared first?
X4.
X to the 4th minus 1 over x squared.
Yeah.
So first of all, we certainly can't plug in 0 because it's infinity minus infinity, right? So we'd like to try to get it into kind of a L'Hopital's rule form. So what we do is we could combine the fractions. We get limit as x goes to 0 of, so this would be, well, it ends up being 1 minus x squared over x to the fourth if you combine those two fractions.
Mm-hmm.
Now, if I plug in 0, though, I don't get infinity over infinity or 0 over 0, which are the only things where you can use L'Hopital's rule. I actually get 1 over 0.
Yeah.
But we know about that from back in the day. We know that, okay, if I have a number over 0 and there's nothing to cancel out the x to the fourth on top, then it's either going to plus or minus infinity. So it's got a vertical asymptote at 0.
Yeah.
So
I was confused. I originally did that, then I'm like, well, it has to equal 0 over 0. So then I like cross multiplied kind of, and then
Right.
like, oh, this is a disaster.
Yeah.
That one was tricky.
Yeah, it was tricky. I mean, and in some sense, I don't want to say I was trying to trick people, but I was kind of testing. Do you understand that the only time you can use L'Hopital's rule is on 0 over 0 or infinity over infinity?
Yeah.
Yeah.
So would you just say can't use it?
Well, what I would say is, so now if I know that if it's going to 0, so what I would do is I'd plug in, well, what if I plugged in a value that was very close to 0? Then this would be around 1, and this would be around 0, and 1 over a very, very small number is positive infinity. So that was the answer.
Okay.
Yeah.
It's a tricky one.
Yeah.
Do you have time tomorrow to come in so we can ask a few questions about the test?
Sure.
Okay.
Tomorrow I should be in my office between like 8 and 9:25.
Okay.
Does that work?
Yeah.
Okay.
And then what did I do
Thank you.
wrong with this one?
What went wrong here?
Yeah.
Yeah. So let me see. The big thing, it actually looks like you did a lot of things.
I'm kind of confused how I got 50% on that.
Yeah.
That doesn't seem like kind of fair.
Yeah, maybe you should have gotten more. But what the main thing was the graph. So the graph, you're going up and you're concave down for a little while. So this thing starts by going up and then it goes down and then it goes up. So here, your graph was just going up the whole time.
Yeah. Okay. I was kind of confused because I saw like the cube. I'm like, that's, yeah, but then, yeah.
Does that make sense?
Yeah.
So I think I would be willing to give you back a few points on that.
Okay. Yeah.
So why don't you bring this by my office sometime? Actually, I could just enter it right here. My computer's here. So I'll change that real quick. I think I just saw the graph and I was like, no, that didn't work out. Oh, I'm still streaming. That's great.